Some worlds tell stories, others preserve them. Orbiting far beyond Earth, deep within Jupiter's realm, is a moon that has remained almost unchanged for billions of years. A world covered in scars. A world that remembers the violence of the early solar system. While planets evolved and moons transformed, Callisto remained frozen in time. Every crater, every impact, every scar on its surface is a page from a history book older than life on Earth. This is Callisto. Among the four great moons discovered by Galileo Galilei in 1610, Callisto is often the most overlooked. Io is famous for its volcanoes, Europa for its hidden ocean, Ganymede for its enormous size. But Callisto remains quiet, distant, and mysterious. Yet this moon is the third largest in the solar system and nearly the same size as Mercury. Orbiting far from Jupiter, Callisto occupies the outer edge of the Galilean moon system. For centuries it appeared to be little more than a frozen ball of rock and ice. But beneath that simple appearance lies one of the most valuable records of solar system history ever discovered. Most worlds change over time. Volcanoes erupt. Tectonic plates move. Atmospheres reshape landscapes. But Callisto experienced very little of that activity. Its surface is believed to be more than 4 billion years old. In many places, the terrain visible today may closely resemble what existed during the earliest days of the solar system. Unlike Earth, where geological activity constantly erases the past, Callisto preserved it. Ancient impacts remain visible. Craters overlap craters. Entire regions appear frozen in a state of permanent geological memory. Looking at Callisto is like looking backward through cosmic time itself. Callisto is composed of a mixture of rock and ice, creating a world unlike any planet in the inner solar system. Scientists believe nearly half of the moon may consist of water ice mixed with darker rocky material. Its surface reflects little sunlight, giving Callisto a darker appearance than many neighboring moons. Temperatures remain brutally cold. No atmosphere protects the landscape. No weather alters the terrain. What exists on Callisto today may remain there for millions of years almost unchanged. It is a world where time itself seems to move more slowly. Callisto's greatest value may not be what it is, but what it remembers. Every impact crater preserved on its surface records an event from the violent youth of the solar system. Worlds closer to the Sun have lost much of that evidence through erosion, tectonics, and volcanic activity. Callisto did not. It became a geological archive billions of years in the making. Scientists study its surface not simply to understand Callisto itself, but to understand the ancient environment from which all planets, moons, and ultimately life emerged. More than 4 billion years ago, the young solar system was a dangerous place. Newly formed planets and moons were constantly struck by asteroids, comets, and planetary debris left behind after the birth of the Sun. This era, known as the Late Heavy Bombardment, reshaped countless worlds. Many of the scars from that period have long since disappeared elsewhere. Earth erased them through erosion and plate tectonics. Other moons renewed their surfaces through volcanic activity. But Callisto remained almost unchanged. The impacts stayed exactly where they landed. As a result, Callisto became one of the most complete records of the solar system's violent childhood. The most spectacular scar on Callisto is known as Valhalla. Stretching nearly 4,000 kilometers across, it is one of the largest impact structures in the entire solar system. At its center lies the location where an enormous asteroid struck the moon billions of years ago. The collision released unimaginable amounts of energy, fracturing the icy crust and creating giant concentric rings that spread outward across the surface. Even today, those rings remain visible. Valhalla is not merely a crater. It is a monument to one of the most powerful impacts ever preserved on a planetary body. Nearly every visible region of Callisto is covered in craters. Large craters overlap smaller ones. Ancient basins intersect with younger impacts. In some places, the surface is so densely cratered that there is almost no untouched terrain remaining. This extraordinary density tells scientists something important. Callisto has experienced very little geological resurfacing. The Moon simply recorded impacts and kept them. Each crater acts as a timestamp from a different era in solar system history. Together, they create one of the oldest and most complete geological archives known. Most worlds evolve. Callisto endured. Its surface preserves evidence from a time when planets were still forming and collisions shaped the architecture of the solar system. Because so much of that history has vanished elsewhere, Callisto became invaluable to scientists. It is not simply a moon orbiting Jupiter. It is a fossil world, a surviving witness from the earliest chapters of planetary history. Every crater, ridge, and basin offers clues about events that occurred long before Earth became habitable. Looking at Callisto is like looking at a photograph taken near the beginning of time. For decades, Callisto was considered a frozen and inactive world. But modern observations have raised a fascinating possibility. Beneath its ancient crust, there may be a buried ocean of salty liquid water. Scientists studying magnetic measurements detected signs that could be explained by a conductive liquid layer hidden deep below the surface. If confirmed, Callisto would join a growing family of ocean worlds scattered throughout the outer solar system. Even this ancient moon may still hold secrets beneath the ice. Unlike Io and Europa, Callisto orbits far from Jupiter's most intense radiation belts. This makes it one of the safest large moons in the Jovian system for future exploration. Some mission concepts even suggest Callisto could serve as a staging point for deeper operations around Jupiter. Astronauts may one day orbit, study, or even establish temporary bases near this ancient world. What once seemed like a forgotten moon may become one of humanity's gateways into the outer solar system. New missions are preparing to study Jupiter's moons with unprecedented precision. Among them is Jupiter Icy Moons Explorer, which will investigate the icy world surrounding Jupiter, including Callisto. Scientists hope to learn more about its surface composition, internal structure, and possible ocean. Every observation helps reveal whether Callisto is merely an ancient relic, or a complex world still evolving beneath the surface. For more than 4 billion years, Callisto has watched the solar system change around it. Planets evolved. Oceans formed. Life emerged on Earth. Civilizations rose and fell. Yet Callisto remained, preserving a record from the earliest age of planetary formation. It is one of the oldest worlds we can still study today, a frozen witness to cosmic history. And as humanity expands farther into space, this forgotten moon may once again become one of the most important worlds in our journey through the cosmos.